Let's go over units and notation. The support material or literature for this can be found under SparkFun or under All About Circuits, all free contents. And we're going to focus on the International System of Units, SI. You're probably familiar with units such as time, or unit seconds for time, meters for length, or grams for mass, Kelvin or Celsius for temperature, or Fahrenheit, Newton for force. But normally for electrical and computer engineering concepts, we're focusing on different units such as volts for your voltage, amps for your electrical current, watts for your power, joules for your energy, ohms for resistance, hertz for frequency. And sometimes these units start getting big or very small, and we don't want to carry those zeros or those decimal places around. So we're going to use something called the prefixes. And when we want to kind of condense the amount of zeros, for example, here I have the number 1000, and I can put these 3 zeros over the power of 3, so 10 to the power of 3. So notice that the number on the top tells you the number of zeros that you have. So 10 to the power of 2 is telling that you have 2 zeros. 10 to the power of 1, you have 1 zero. 10 to the 0 is the exception, it's the unit. So it gets you just 1. Then when you start going to power negative powers, 10 to the minus 1, it's telling you how many decimal places you have. So minus 1, you have 1 decimal place. Minus 2, 2 decimal places. Minus 3, 3 decimal places, and so forth and so on. So we can describe the large. We are familiar with the 1000, which is this one, the kilo. But if we have 6 zeros, we go to mega. If we have 9 zeros, we go to giga. If we have 12 zeros, tera, so forth and so on. And the same thing we have to describe the small. So when we have minus 3, we have the milli, minus 6, the micro, minus 9, the nano, minus 12, the pico. So next, I have an activity. If you took Intro to Mechatronic Systems 1, you are familiar with these conversions. You can practice these if you don't remember. If you're taking this for the first time, I highly recommend you guys to pause the video before you check the solutions on Canvas and practice. I'm going to do just a couple, teach you a couple of tricks that you can use to check your answer. So let's do the first one, where you have your 50 milliamps. So I can write this differently. I know that milli is times 10 to the minus 3. And then my units are amps. This is what I want to go. Minus 3 means that I'm going to have 3 decimal places. So I can substitute all these by 3 decimal places on my 50. So if I pick up my 50 and I go and I move the decimal places, what I have is 1, 2, 3, and that's your decimal place. And this is amps. So here you go, 0.05 amps. It's your answer. How do you know that this is correct? Well, notice here that my unit here is milli, and I'm going to amps, which is a bigger unit. That means that my number needs to be smaller. And it is, because the first one is 50, and now my answer is 0.05. So I'm on the right track. Let's do another example. Let's go and do, for example, number 3. Number 3, we have 500 kilowatts. I can write this as 500 times kilo is 10 to the third. That means now, and my units watts, that I'm going to add 3 zeros in front of the number 500. So I get 500, 1, 2, 3 watts. How do I know that this answer is correct? So again, I'm going from a bigger unit to a smaller unit. That means that my number needs to be bigger, which it is, 500, and I go to 500,000. So I'm on the right track. Give it a try and then check the solutions on Canvas.